So for today, you prepared by reading about making decisions in the code. So for example, we want to make some decisions based on what the user does when we're running our scripts. And I was thinking that before you start working on the tasks from lecture 3 on your own, I will do one example so we can do one together. And even before that, I also want to cover the quiz that you guys did for today. And I will also talk a little bit about some of the questions that I've got, because I've got quite a few questions about examination 1 over the past few days. So I thought that I will talk about them here because there's probably more of you guys wondering about the same things. So we will talk a little bit about that. But let us start by talking about the quiz. For the quiz for today, there were 94 out of 156 registered students who did the quiz, and that is roughly 60% of you who choose to do the quiz, and it took you roughly, in general, 11 to 12 minutes to do the quiz, and it went very well. The average was that you had 87% correct answers. So I think that is a very good number. You did well on the quiz. So well done on the quiz, those of you who did it. The quiz is good for 2 reasons. One, of course, it gives me some idea if there is an area that a lot of you have not quite understood, then I can talk more about it. But it is also good for you guys. So I would recommend that more of you do the quiz, because it allows you to get an understanding of if you're on the level that you should be. And what I mean by that is, if you do the quiz and you can answer all the questions, it's no problem at all answering the questions, great. But if you do the quiz and you find out that you gave the wrong answers, or you're struggling with finding the correct answer, or you're just a little bit unsure about any of the answers, then it might be a good idea to go back and read the chapters from the book again, just so that you know that you have the understanding of what we're covering this week. And as I said, the result for today was that 80% or 87% correct answers. So there wasn't any big issues. There was no question where a lot of you guys had problems. There were a few wrong answers here and there, but generally speaking, I would say that it went very well. And if there is something to talk about the quiz, I think it must be that you should not stress when you're doing the quiz. Take your time and do it. Think about the answers and be careful with what you answer. There were, of course, some answers that were completely wrong. For example, if you were to write the word "and," I think that was one of the questions today where you should answer "and." And some answers were just pure guesses. Like instead of "and," someone wrote maybe the number 15 or something. So it's a complete guess. And of course, that is wrong. But there was also quite a few answers that was close to the correct answer. But maybe you wrote a little bit too much code or a little bit too little. So be careful, read what you have and what you're expected to input. So maybe if you're expected to input one word, because you don't have to input the rest because it's already there in the script, then don't write too much. There was also in a few cases where the answers that I saw they would have been correct in another programming language, but they were not correct in Python. So my interpretation of that is that it is someone who have been programming since before and was just by habit or just didn't think about it, wrote the syntax from another language. So maybe a warning here, even if you have been programming since before, it might be advised to still go over the material for each week and make sure that you're on board with the new syntax. Remember, even if you have studied before, you are recommended to study full time each week. And with that, I think that is what I will talk about the quiz for today. I won't go into all the individual questions, especially since you did so well on them. We will see some of the... one second here. All right. We will see some of the syntax later on when we have an example, so we will see it there. And instead, I was thinking that I could talk about some of the questions that I've got about examination 1 the last couple of days. And some of the questions are, do you have to use, or do you have to buy a program to do the flowcharts? As other questions are, do you really have to pass all the automatic tests? And when should you start working on the tasks that we're going to hand in roughly 2 weeks? I think the deadline is in the end of next week. So when should you start working on them? So as we can see here, I have kind of tried to draw the first 3 weeks that we have of the course, or well, week 2, 3, and 4 of the course. And my recommendation is to start working on the first task from examination 1 as soon as possible. We see here, I saw that I wrote that you could start with the report now, basically. You could do step 1 and 2 from Polya's problem solving technique. This, as we can do this as we last week talked about and practiced analyzing tasks. So you can start doing that for the task that you're going to hand into now. And then I would say that maybe after today, you can start looking at the programming too. You don't have all the tools yet. We will cover loops next week. You will need those. But you can start to at least solve parts of the hand-in tasks after today. So that is how I see it when you should start working on the tasks. And even if what I'm going to say now sounds a little bit counterproductive, and I just said that you can start on it right away, I still think that you shouldn't stress with the hand-in. It is better to take the time to do the tasks from the book, or the tasks from the lectures, reading the book, watching the videos, and also doing the tasks from the exercise, as this will prepare you for doing the task that you're going to hand in. So even if it sounds like it's more to do, I would recommend doing all of these things before or concurrent with solving the task that you're going to hand in. I hope it makes sense. If we practice it a lot, the things that we're going to use for the handing task, then when you come to the task that you're going to hand in, it's going to be easier to solve them. So just make sure that you understand all the concepts. All right. Back to us. I'm gonna mention a few more things here. And that is that you don't need to buy any program to do the flowcharts or the pseudocode. There is one recommendation in our discussion forum that you can use AlgoBuild if you like, but that is not a requirement. You can also draw your flowchart or your pseudocode on a piece of paper, take a photo of it, and include that in the report. So there's no need to buy a specific software to do the flowcharts in. And also, when we talk about the tasks that you're going to hand in, you have to be very thorough when you do them. You have to pass all the automatic tests. So you need to have all those small green check marks. And the automatic tests are very picky, as I've mentioned before. The result that is printed from your script must match exactly what is expected. Every space, every character, every number, everything must match exactly. And this is by design, because I want you guys to prove to me that you can format your output. So just make sure that when you hand them in, that if you get a failed test, just reflect on why it failed, check the expected outcome, and then also check what your script actually output, and then compare them character by character. Maybe it's expecting uppercase, but you didn't have an uppercase letter for some of the letters, or maybe you have more spaces or less spaces. So compare it carefully and analyze why did it fail, then go back, correct those problems, and upload again. Because as we have mentioned before, you can upload as many times as you like before the deadline. So if it fails, just correct it and upload it again. And with that, I think it's time to look at a problem that we're going to solve here before you guys start working. So let me just switch to the problem description so I can share that with you guys. So this is the problem I was thinking that we should solve together today. So I'll give you a minute or so to read the problem description, and then after that we're going to start working on it. So I will let you read it, and I will be back in a minute or so. All right. So I'll stop sharing it. It will be back on the screen shortly, but I'll stop sharing it. And then I will just prepare my screen here. Give me a second. Now you should be able to see the text again, and also my iPad. And if we get a task like this, any task, what we should do is that we should first analyze it. So we have Polya's problem solving technique, and we should try to get into the habit of using it. And what I'm going to do now is that I'm going to try to show you all the 4 steps. And the first one is to understand the problem. And we have the problem here. So what I'm going to do is that I'm going to try to read it. And the first thing I see here is that it tells me that we need to input something. So input a position that has X and Y values. All right, so that's going to happen. But what's going to happen after that? If the values are both greater or equal to 5, the script shall construct a new string on the format parentheses x comma y parentheses. All right, so then I will mark, I think, this bit here to say that, all right, we input some position. After that, we're going to decide if both of the values are greater or equal to 5. If they are, we're going to construct a new string. And then it also tells us that we should display it to the user. And the next thing in the script here is that it says that, all right, on the other hand, if any of the values are less than 5, the message not valid shall be displayed. All right, so then I will mark this bit here. Then we see here, when I read this is how I interpret it. That, all right, we need to input something, x and y. After that, we're going to decide if both those values we inputted are greater than or equal to 5. If they are, we are going to create a string on some format and print it. And if any of the values is less than 5, we're going to do the last bit here and print not valid. So I think we have a pretty good understanding of what we need to do. But what we can do is that we can also, just for our own sake, we can make an illustration so we know 100% sure that we understand what we need to do. And I did this illustration here where I say that, all right, everything greater than 5 and greater than 5. So that's blue here. There we're going to format the new string and print it. But everything that is white here, that's going to be not valid. I'm just trying to keep track of chat at the same time a little bit. So we can do an illustration too. But now that we have an understanding of this, now we have done the first step of Polya's problem solving technique. And the second step is to devise a plan. So now we're going to come up with a plan for how to solve this. And in my case, what I'm going to do is that I'm going to do a flowchart for it. We're going to see if you guys see if I start typing here, maybe. Let's see. Yes, we see here. Start. So when we do a flowchart, we must start somewhere. And let's start here. The first thing that we marked in our text, how we understood that we should do it, is that we should read 2 values from the user. So I'm going to input that into my flowchart. All right, and when we have that, the next thing that we need to do is the part in green here. The values are both greater or equal to 5. The script shall construct a new string on the format xy. All right, so how should we do that in a flowchart? Well, maybe something like this. So here we're going to make a decision, and out of this we will have what will happen if we answer yes. So if both values is greater than or equal to 5, what should we do then? We are still on the green part here, so we should do the following. We should create this new string given some format x, y, and after that we should display it to the user. And now that we have this part here for the yes side, we'll go and do the no side. So if we have this decision here that we should make if both x and y are both greater or equal to 5, but what if we answer no here? What should we do then? I'll just zoom out a little bit so maybe we can see both of them. All right, so when we come to this decision here, we can answer yes or no. If we answer yes to the question, we go to the right-hand side. If we answer no, we continue straight down. And after that, there is nothing left to do. So what we will do then is go to, maybe I can make it a little bit smaller. We can do this. Then we are done with our script. So if we look at all of it at the same time, now we can look at our plan, and we can also look at the text that we have on the right, and we can start to think, have I covered everything in the text in my diagram? So we should input X and Y, we have that. We can also think about the two other parts that I marked in color here, the green and the, what do you call that color? Blue, let's call it blue or cyan. The green part is yes, so that is on the right hand side, and the cyan part is what goes straight down when we say no for that decision, and then we end the script. So we can kind of validate that we have a solution that works even before we have actually started to write any code. But that is the next step. Now that we have done the second step from Polya's problem-solving technique to devise a plan, the next step is to carry out the plan. And I will stop sharing this, and I will prepare my screen with Visual Studio Code so that we can write the code too. Just give me a second here, and we will see if we can show everything on the screen at the same time. Can you see Visual Studio Code?
Yeah, we can see. Can you hear me?
Yeah, great. Thank you. Good. But before we continue writing the code, Niklas, is there anything I've missed in the chat? Any questions or anything?
No.
Okay.
Not what I can see. I've tried to answer those that were there. So
Good. All right. Then let's do the third step here of Polya's problem-solving technique. We have now devised our plan, we have it on the right-hand side, and it's time to write the code. And the benefit we have now, when we have the plan, is we have the recipe for what we need to do. Now we just need to write the code for it. But when writing the code, we don't have to solve the problem at the same time. We have already solved it. We have a plan for how to carry out the plan here, so we know what we need to do. So I will just start writing the code for it. The first step is to read X from the user. And let's give a message here so that the user knows what to do. Specify X maybe. The second step is to read Y, and that is very similar to reading X, so I'll just copy and paste that one. So now we have done the first two steps here, and we see, all right, it's time for a decision. This is what you studied for today, so time for an if statement here. And we can see here from having done our plan that we should say that, all right, if X is greater or equal to 5 and Y is greater or equal to 5, then we should do something. We are now on the right hand side here, so we should create this string output on some given format. So output is equal to, and I'll use an F string here, to say that, all right, the format will be parentheses, those are hard-coded. The comma and the space in the middle is also hard-coded, but as it is an F string, the parts within the curly brackets will be replaced. So they will be replaced with our values that we read from the user for X and Y. So we have constructed that string. If we continue looking on our plan, we could see here, all right, we shall display the output. So we can do a print output. There we go. And we can see here there is nothing more we need to do in this if statement. But we have one other part here. So if we answer no, so in all other cases, we should display that it's not valid. So then we need an else statement here to say for all other cases, if X is less than 5 or if Y is less than 5, then we need to print not valid. And we see after both of these, there is nothing more to do. We are now at the end for both of these branches here. So we can look at the code now, compare it to our plan. We can see that it matches. So it's going to be exciting to run it and see if it actually works. So if I give some values here that are both greater than 5, we can see that, all right, it goes into the if statement here, and it constructs the output string, and then it displays it. But what if we run it again and one of the values is less than 5? Are we going to go into the else statement then? Yes, we see that. All right, then it goes in here and prints not valid instead. So hopefully you can see that having a structured way of approaching problems, each step becomes less, how should I say it? Each step becomes easier because you are just taking one small step ahead. First we did try to understand the task. After that we devised a plan. Now that we have the plan, we can implement it using our plan as a base. And of course this task, it's a small task, but you can imagine if it is a bigger task that you're going to work with, how much of a benefit it would be to have this plan or this recipe for what you need to do in your code when you're writing the code. Instead of having sit down, try to write the code and solve the problem at the same time. The last step in Polya's problem solving technique is to verify that you solve the problem that as it was stated, and to look back and see what you have learned, so you can take it with you in the future. So we should not forget the last step too. All right, is there any questions? I'll just check here in the chat for a second. There is a question here about if F strings always produce a string. Yes, they do. What is the point or the importance of the curly brackets? The curly brackets, as we can see them here, you can see them as placeholders. So we are going to construct a string here, and we are using an F string, so a format string. The things, if I just do like this, if I remove them completely to begin with, what we see here is a string. It's a regular string. If we try to print it, it will look exactly like this. But the benefit of using an F string is that we can use our variables to print whatever is stored in that variable. And we do that by including the curly brackets here. So if I write what I just had here, like this, it means that, all right, construct a string which starts with an opening bracket, and then this part here, which is, which is the curly brackets, replace all of that with whatever is stored in the X variable. Then the things that is outside of the curly brackets, print those as they are. So it prints a comma and a space. Then it's time for a new curly bracket or a new placeholder. So the things that I have marked here in blue will be replaced with whatever value we store in y, in the variable y. And then finally, after having replaced y with the value from the variable y, it also prints one last closing parenthesis. So I hope it makes sense why we have the curly braces and the importance of them. The importance is that they mark what should be replaced. So they mark where we put our variables.